Okay, students, we are talking now on section 1.7. We will talk about quantities in physics. Now we'll talk about scalars and vectors. But before we'll talk about quantities in math. In math, we have just numbers and samples, and there are no physical meaning for these numbers or samples. But in physics, we have a meaning for each magnitude, and we have a units or directions for vectors. For scalars, we need to mention just the magnitude and the unit. It's just like the mass. If we say 5 kilograms, 10 kilograms, or the time like 3 seconds, 4 days, the distance, which is the distance between 2 points, the work in joule. For these quantities, we can't mention that the quantity or the measurement of the time is to the right or to the left or upward, downward, or something like that. This means it is a scalar. And the operations of for these quantities are simple. Just if we need to add 3 seconds to 4 seconds, it will be 7 seconds. If we need to multiply two numbers, two quantities, it will be easy. But in vectors, we need to mention the magnitude and the unit and the direction. For example, displacement, which is the shortest, which is the straight line between 2 points, we need to start from a point to a point, for example, from A to B. And we need to say the direction to the right, to the left, to the north. Velocity also is a vector. It is different than the speed. We will talk about them. We know them later. The acceleration, the force, the weight, all of them have a direction. They are vectors. They have more complex operations. For example, if we add two vectors, for 1 plus 2 or 1 plus 1, it will not be 2. It may be 0 or maybe -1 or any value between them. We will see that in examples and in the class in the future. Now, for a vector A, each quantity in physics or in math, we need to name it. If we have a vector and if we name it as A, we need to write it and draw an arrow over it. This quantity is a vector. Also, we can write it or type it in bold fashion. In this way, it will be also a vector. We need to draw a vector in our problems. So how to represent a vector or draw a vector? The vector is a straight line. Its length indicates its magnitude, and it ends with an arrow indicates to its direction. For example, we have this vector A, start from here to here. If we need to see its length, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, I think it is 14 units. If each dash is a unit, and the direction is to the right, downward. The vector minus A, it is also 14 units of length, but with opposite direction. This is the vector minus A. Look at this vector, which is B. It is 2, 4, 6, 7 units to the right, upward. The vector minus B, it is the same length, 7 units, but with opposite direction. Look at the vector A, it is its length and its magnitude is more than the vector B. Also, the direction for the vector A is different than the direction of vector B. The negative of the vector is just the opposite of the vector by reflect that direction of the row. Look here for two vectors C and D. They direct upward to the y direction, but they are different in the length. So the vectors may be long or short. This way we can draw the vector. We need to know its direction and its length. If we need to look at the addition of vectors, we have these two vectors in the same direction, A and B. Look at them. If we need to add them together, the vector A in bold fashion, we don't have an row over A or B. If we need to add A plus B, we need just to take A and drag B and put the start point of B at the end of A, head to tail, and then we can add them together, and the resultant vector is the orange one, which is, we can name it C, for example. So this is A plus B, which is equal also to B plus A if we put B at the beginning and A at the end. This is the addition of two vectors in one direction. What if we have different directions for these vectors? This is A and this is B. We need to add them together. At first we need to take A, this is A. Then we need to take B and put its tail at the head of A. This is B. And this is the resultant vector, which is equal to B plus A. Look at here. We have, this is B at first. Then we put the vector A. And this is the resultant vector, which is the same direction and the same length. If we have two vectors with the same direction and the same length, then we can say that they are equal to each other. By seeing that A plus B is equal to B plus A, we can note that the vector addition achieves the exchange property. The drawing method. This is drawing method for addition of the vectors. We put the second vector at end. We pull the second vector and we start at the end of the first one, which is tail to head. In this way, look, in vectors, the addition process, it is not simple. This is A plus B, and this is A plus B. We have the same vectors, A and B, the same length for A, but we have different direction. The same vector B with the same direction. But we have different magnitude because there is an angle between A and B. The change in angle between vectors will change the magnitude of the resultant vector. That is why I talked before and I told you the addition process is not simple as the scalars. The subtraction of vectors. If we have the vectors A and B again, we have this A and this is B, and I need to find A minus B. It is easy. We know from before that minus B is equal to B in length but in opposite direction. Okay, A minus B, I can use this minus sign and put it for B. So I can add A plus minus B. This is B, this is minus B. Just I exchange the direction. Okay, I know how to add two vectors. I use the first one, which is A, this is A, and then add minus B to it. this is minus b. This is a, this is minus b, and this is the resultant vector, which is a minus b, or a plus minus b. We'll try that in the class. Let us try now b minus a. It's easy. We can use the minus sign for a. It will be minus a. Then we have the plus sign. So b plus minus a. I will use b at first, which is the blue vector. Then I use minus a, which is the reddish vector. And the resultant vector is b minus a. It is the same length as a minus b, but it is in the opposite direction. So you need to note that the vector subtraction does not achieve the exchange property. And the method of the subtraction is by drawing. We pull the negative of the second vector and place it at the beginning, and place its beginning at the end of the first one. You can use the fit simulation site to play with vectors and add them together. Okay, we have vector product. We will face this operation in the future many times, but I will talk briefly on it about it now. We have more than 3 ways to product for vector product. This one is the cross product, which is a cross b. The resultant vector, if this is a and this is b, the resultant vector is this one, is a vector also, and this vector is perpendicular on b and a. If we have the red vector and the green vector, the cross product between them is the blue vector. It is perpendicular to their surface. If we need to know what is the magnitude of this new vector, it is the length of A multiplied by the length of B multiplied by the sine theta between them. If theta is 0, look here, when the theta between the green one and the red one is 0, the angle between them is 0, then the blue vector will be equal to 0. Also, we have the dot product. If we have A dot B, the resultant is a scalar. It is not a vector. And it will be the magnitude of A multiplied the magnitude of B multiplied by cosine theta. We will face this process later when we work with work, which is the force multiplied by the displacement. We have also the scalar multiplication. If we multiply 4 by the vector A, it is just A 4 times. If we have this is a vector A, for A it is the same vector A but 4 times. So we have a new vector with the same direction but 4 times length. It is easy. If you walk 1 step or 4 steps in the same direction, it is a scalar product with a vector. Okay, let us now deal with these vectors. Sorry. If we have this bird, for example, need to move from the tree 1 to tree 2. It can go directly. using this way. This is a vector. We can name this vector any name you want. We can name it as V, for example. You are free. And it can go in different ways. For example, it can go using the vector A, which is in bold. We can use also A with an arrow over it. And it can go using the direction for vector B, which is the blue one. I'll make it in this direction. Okay. And the third step, it can go this way with vector C. We can add more than one vector to give us a resultant vector. We have a position vector, for example. A position vector in general named by R. So the tree number 2 is positioned with vector R with respect to tree number 1. We have velocity V. If we divide the distance over the time, it will give us the velocity. We have the acceleration vector. We have the force vector. If we add two equal vectors together, look at here, please. We have this vector and this. If we change the direction, I just change the direction of that vector. So if I have this vector A and this is vector B, if I add A plus B, the result is 0. Okay, in this case, if we have if I make this process A plus B, it will be equal to 0. This will give me a result that A is equal to minus B in vector notation. Okay. Now, there are important relations. We need to focus on them. I think they are explained well in the block which is in the canvas, mathematical part. We need to know how to use the Pythagorean theorem. We have two sides for this right triangle. The side, the hypotenuse, I don't know, the adjacent, the opposite, okay. You know that h squared is equal to g squared plus f squared. And you need to know how to find sine theta and cosine theta and tan theta. For example, sine theta is opposite over the hypotenuse, and cosine theta is the adjacent over this, and the tan theta is this over this. We will use these relations many times in the future, and I think you will be fine with them. Thank you.